Now, before I move on to the reduction formula for sec, please watch my video for the reduction formula for sine, tan, and cos. And we should make some comparisons for you to better understand. Because the way we derive the reduction formula for sine is similar to cos. The way we derive the reduction formula for tan is similar to cot. And of course, if I do sec, it would be similar to cosec, right? So you can do those ones. All right, let's get right into it. Now, since we're going to be applying integration by parts here, if I were going to rewrite this, how would I rewrite it? Would I rewrite it as sec times sec to the n minus 1? No, because now I would have sec to integrate, which is going to be a complex process. However, if I were to write it as in equal the integral of sec to the n minus 2x sec squared x, this would be much simpler because I know that the integral of sec squared x is tan x. Pretty straightforward integral. And of course, we can differentiate sec to the n minus 1x. So that's not a problem. So we're using parts, so it says the integration of u dv is equal to uv minus the integral of v du. Now u would be equal to sec to the n minus 2x, and the dv would be equal to sec squared x. Alright, so du. Once again, we come back to the chain rule, which says we bring the power to the front, so we have n minus 2. We subtract 1 from the power, so we have sec to the n minus 3x. And then we multiply by the differential of sec x. Now, the differential of sec x is, of course, sec x tan x. Alright? We have this to tidy up. Let me just split this so you don't get confused. Now, by laws of indices, if you multiply sec to the n minus 3 times sec x, the bases are the same. We add the powers, so we're going to have du is equal to n minus 2 sec to the n minus 2x tan x. Alright, good. V is simply going to be equal to the integral of sec squared x, which you know to be tan x. So we have that part covered. Giving myself some more space. So we can say that in, based on integral by parts, is uv. So we have u, we have v, so we have sec to the n minus 2x tan x minus the integral of v du. So v du is down here. Now, this is going to be n minus 2 sec to the n minus 2x. Of course, when this tan x multiplies this tan x, we have tan squared x dx. Do not leave out the dx. Now, this is wonderful because now we can get this thing back in terms of sec only, because we know that there's a connection between tan squared x and sec squared x. We know that 1 plus tan squared x is equivalent to sec squared x, which means that tan squared x is equivalent to sec squared x minus 1. And this is exactly what we need to get rid of. The tan squared x to get it back in terms of sec. So you're going to have in equal sec to the n minus 2x tan x minus, and of course we can pull the constant out now. So you have n minus 2, which is a constant on the outside. And of course I'm going to change the tan squared x to sec squared x minus 1. So I'm going to bring back the sec to the n minus 2x, and I'm going to replace the tan squared with sec squared x minus 1. Do not leave out the dx. Alright, I'm going to need space, so let me just reduce as I go along. Now, what do I do next? At this point, since we have a difference here, we can split this integral. And because in the previous question we did it, split it step by step, we're going to split it all in one. So we're going to expand and split. Bear in mind that the minus n minus 2 is multiplying all this. So whenever we split it, it's going to multiply the terms individually. So I'm going to have in equals sec to the n minus 2x tan x. Alright, look at this now. Now, when sec to the n minus 2 multiplies sec squared x, by laws of indices, the bases are the same. You add the power, you're going to get n. Bear in mind also that you're going to split the integral because you're going to have a difference between the two of them. And of course, you have the minus n minus 1 here, so you're going to multiply by that as well. So I'm going to have minus n minus 2, sorry, not n minus 1, n minus 2, integral of sec. And of course, when we add those powers, 2 to n minus 2, we're going to get 2x dx as 1. Now, because this is a negative 1, when I multiply it by this, I'm going to get a positive. So I know that that is going to be a positive n minus 2. All right, bear in mind that we're going to be integrating that part. So when I multiply sec to the n minus 2x by 1, I'm going to have the integral of sec to the n minus 2x dx. So we did everything in one. In the previous video, we broke it down step by step. But after a while, you get familiar with the steps. So you can do that. Now let us look at the original integral. Bear in mind that in was the integral of sec to the nx dx. Looking at this right here means that, oh, there's a little error right here. So by laws of indices, we add n minus 2 and 2, we would have gotten n. All right, so a slight error right there. Now, based on the original integral, sec to the n minus 1x, the integral of it, this would be in, and this would be in minus 2. So I'm going to have in equal sec to the n minus 2x tan x minus n minus 2 in bracket in plus n minus 2 in minus 2. This is not too far from how we approach the integral for cos, because notice that you have in on the left and on the right. So you know we're going to have to bring all of them to one side. So I'm going to have in, you bring over all of this term right here, it's going to become a positive n minus 2 in is equal to sec to the n minus 2x tan x plus n minus 2 in minus 2. So far, so good. Okay, create a little bit more space here now. So, factoring out in, I'm going to have 1 plus n minus 2 is equal to sec the n minus 2x tan x plus n minus 2 I subscript n minus 2. Good. So good so far. Now in bracket, 1 plus n minus 2 is going to give me n minus 1. So I have n minus 1 in is equal to sec the n minus 2x tan x plus n minus 2 I subscript n minus 2. So in, we simply divide all the terms by n minus 1, which I told you before, we can write it as just 1 over n minus 1 sec to the n minus 2x tan x plus n minus 1, well, n minus 2, sorry, over n minus 1 I subscript n minus 2. Now, clearly, this is also a scenario where n should be greater than or equal to 2. So let me just put that in. N is greater than or equal to 2. Very important there. So this would have been my reduction formula for sec. So you just have to watch your brackets carefully, look at your signs, and simply break it down as you go along.